This is 5.2, the definite integral. Let's consider this situation. This may sound familiar if you took or are taking physics. An object travels in a straight line at a constant velocity of 5 feet per second for 10 seconds. How far away from its starting point is the object? 50 what?
Feet.
50 feet, yeah. Pretty simple, right? It's just like a distance equals rate times time situation. So the rate would be the 5 feet per second, and then the time is the 10 seconds. And if you remember from like chemistry, when you did like dimension analysis or unit analysis, whatever they call it, you've got the seconds in the denominator and the seconds in the numerator, and so those just reduce to 1, so then your units end up being feet. So we can represent this situation with a graph. So this is what's called a velocity time graph. So along the horizontal axis, we are measuring time in seconds, and along the vertical axis is the velocity in feet per second. So does it make sense to you that red line would represent a constant velocity of 5 feet per second? If I go out to 10 seconds and I draw like a vertical line and I shade that region, so that gray shaded region would represent traveling for 10 seconds at a constant velocity of 5 feet per second. And what shape have I created? A rectangle. And what would be the area of that rectangle? 50. Okay, so again, if you've taken physics or if you're in physics, you may have heard that the area under a velocity time graph represents the distance traveled. Okay, we're not going to do too much with finding distance traveled in this class, but this does relate to the whole idea about area under curve relating to finding that what if the velocity was, or what if we were moving backwards? What if that object was moving backwards?
That'd be negative.
Then your velocity is negative. And we've talked about that before, like we did a problem the other day when the velocity was negative and we talked about how that meant the object was moving down. If you have a constant velocity that's moving backwards, so a negative velocity, then your line is below the x-axis. And then if we're, in this case, if we're doing 2 feet per second for 4 seconds, we still are going to have a rectangle, but what would the area of that rectangle be? -8, okay? So when area is above the curve, above the x-axis is positive, and when it's below, it's negative. Areas that are under the x-axis are negative. So you're probably wondering, what does this have to do with integrals? All right, so 5.2, the definite integral. So your definite integral is basically your total signed area. So what we're looking at here, we have the same integral sign that we've been working with, but now we've got like a subscript and a superscript here. These are known as your bounds of integration. The lower number is going to be like your starting point, and the upper number is going to be your stopping point. So in other words, if I had a graph, and let's say that this A could be over here, and B could be over here. Okay, so this is going to be your lower bound, and that's usually to the left or smaller than the upper bound. I don't know, it's been a long time. Okay, so one little region there in orange and one region there in purple. So when we see the bounds here, then this is known as the definite integral from A to B. The definite integral from A to B. If you don't have those bounds, then it's just the indefinite integral. And A and B are your bounds of integration, period. They are the bounds of integration. The total signed area, so this represents the total signed area. This notation represents the total signed area from A to B, from x equals A to x equals B. So the total signed area, if you're wondering what that means, that is equal to the area under the curve. So up here with this graph that I drew, if that was a graph of f, it would be the area that's under the graph of f but above the x-axis. So like that region I have there that's in orange, minus the area that is above f and under the x-axis. So if we were to put some numbers on here, like maybe this area is 5, this orange area is 5, and maybe the purple area is, it looks like it's smaller, right? So maybe it's 2. The total signed area would be what? 3. The area above the x-axis is positive, the area below is negative. So it's very similar to what we're going to see here in this next slide. So here we have from A to C, and that whole thing from A to C is 15, and then from C to B is 3. So then what would be the signed area or the definite integral from A to B? 12. All right, so what do you have for this one over here? 8, and here, 0. Now if the area below the x-axis had been larger, then your total signed area could be negative. Okay, so don't worry if you end up getting a negative value or 0 for a definite integral. It just means that either the areas cancel each other out or that the area below is larger. So let's take a look at numbers 1 through 4. We're going to have to use a little bit of our geometry skills. So number 1 is you're given this graph here, that's F, and they want to find the total signed area from 0 to 3. So 0 to 3, so here's 3. You may want to draw like a little vertical line here, and maybe you shade it. And what geometric shape do we have?
Triangle.
A triangle. Well, we know from geometry how to find the area of a triangle. Well, it's 1/2, and then the base would be like from here over to here. So that's 3. And the height is also 3. So that is, right, 9/2 or 4.5, whichever you prefer. I don't mind. Okay, do number 2. What do you have for number 2? Yeah, so this time you're looking at a different, it's not a right triangle anymore. It's this whole scaling triangle. So it's going to be 1/2. This time the base is going to be 5, and the height is still 3. So that is 15/2 or 7.5. All right, let's take a look at number 3. They want us to go from -4 to 0. What shape is that, from -4 to 0? That's a trapezoid. Now, you could easily figure out that area just doing like a rectangle and a couple of triangles, and you would get the right answer. But it'll be useful because we're going to be doing trapezoids later when we do the trapezoidal rule. Michael, eyes up here, please. So then the area of a trapezoid formula, you guys remember? Yeah, that's okay. I don't really expect you to remember. It would be 1/2 times the height times the sum of the bases. Let me just remind you what the bases are. So trapezoids, by definition, have one pair of parallel sides. And those are your bases, the ones that are the parallel sides. And then the height is the distance between the two bases. So what do you have there for number 3? -5. So that would be 1/2. And like I said, the height, since we're going down, I'm going to call that a -2. And then one base can be this from the -4 over to the 0. So that's just a 4 plus. And the other base would just be this little line segment, which is just 1. So then that's -1 times 5 or -5. All right, what shape do we have on number 4? A semicircle. So what's the formula for area of a semicircle? Yeah, 1/2 pi r squared. So you can leave that in terms of pi if you'd like for number 4. So 1/2 pi, and then the radius would just be 1. You can see the diameter is 2, so the radius is 1 squared. So you can call that half a pi if you'd like. We often in trig call that pi over 2. As a decimal, that's about 1.57. All right, let's talk about number 5. So this time we're going from 0 all the way over to 7. It's the same graph as the other questions. So we can just use the same information that we found before. So going from 0 to 7 means you're going to use that larger scaling triangle and the semicircle. So what do you have there? So that would just be the 7.5 plus the 1.57. So that is 9.07. All right, so then for number 6, you're going from -4 all the way over to 5. So that would be the trapezoid plus the scaling triangle. So how much is that? Yeah, so it would be the -5 for the trapezoid, and then a positive 7.5 for the scaling triangle, so 2.5. What do you think what's the difference between number 7 and number 1? You are going backwards. So what do you think that means about the area? It is negative. So this is actually negative 4.5. So you're going to want to pay attention to that. If the lower bound is larger than the upper bound, then you're moving from right to left instead of left to right. And in that case, it's negative. And we're about to talk about that with one of our properties of definite integrals. Okay, there's 5 properties of definite integrals we're going to talk about. The first one is called your additive interval property. So it says that if you are doing the integral from a to b of f plus b to c, that's the same thing as going from a all the way over to c. So you can just call this integral from a to c. Okay, for the sum difference property, we had this property when we were talking about the other integrals a couple of days ago. So this just means that you can split that up. So you can go from a to b of f of x dx plus or minus the integral from a to b of g of x dx. The next one is the zero property. You can probably figure out what we're going to put here. The integral from a to a is going to be 0. Then we have our opposite property. So the integral from b to a is going to be the opposite of the integral from a to b. And that's that property that we just saw from example 7. And the last one, the constant multiple property. We also saw this a couple of days ago with the indefinite integrals. That it just means that you can take the constant on the other side of the integral sign. So have a go with numbers 8, 9, and 10. All right, so for number 8, It's very similar to number 1, but except you have the 2 there. We can take that 2 out to the front because that's a constant multiple property. And then you're just going to go from 0 to 3. Oh, this is a different graph. So you're going to go from 0 to 3, which is another trapezoid, and then double it. So we can say that it's going to be 2 times, and then the trapezoid formula is 1/2 times the height. What's the height of this trapezoid? -2. And then base, the sum of the bases. So base 1 could be that one. How long is that base? 3. And how long is the other base? 2. And then you've got some things that reduce, right? 1/2 times -2. Well, or you can just do that one. So you've got -2 times 5, which is -10. All right, number 9, we're going from 0 to 5. So not too different than what we were doing earlier, just that we now know that if we wanted to, we can write this extra step by saying, well, I can see that the graph is broken at 3. It's like crossing the x-axis at 3. So we can say, well, why don't we go from 0 to 3 of f of x dx plus the integral from 3 to 5 of f of x dx. And no, you don't have to write that step if you don't want to. But 0 to 3, that is going to be, well, that's the 1/2 times the -2 times the 5. So that's going to be -5. And then 3 to 5, what shape do we have there? A triangle. So that's going to be 1/2. And how long is its base?
3
2. And its height? 2. So that area there will be 2. So -5 plus 2, -3. Now, number 10 is tricky because this is different than number 8. And that number 8, that was a multiple, right? A constant multiple, and that allows you to take the 2 at the front. But number 10, if you just have a constant plus your function, you cannot just manipulate like we did number 8. So what we have to do is actually, we're going to split this up using that additive, no, we're going to split it up using the sum difference property. So we're going to say, why don't we go from 0 to 5 of just 2 dx plus the integral from 0 to 5 of f of x dx.
Yeah.
I'm going to get there in a minute, but does it make sense what I wrote down? Okay, well, this is something that you're going to see on your quiz, and a lot of students mess this up because they're not sure how to handle the 2. But remember, this is like a function, right? This can just be y equals 2. What does the graph y equals 2 look like? All lines are straight.
Horizontal.
A horizontal line. So it's just a horizontal line like that, yeah? And we want to find the area under that graph from 0 to 5. So if 5 were here, you're looking at a rectangle, and the area under it would be then 10. Okay, so that's additional steps there that you have to think about what that graph looks like. What geometric shape does it fit? And it's just a rectangle. So that's just going to be 2 times 5 plus, and then the 0 to 5, we did that earlier, right? -3 plus -3. So 10 minus 3 is 7. All right, let's take a look at number 11. On number 11 and 12, you're not given pictures anymore. You're just given information about the definite integral. So you're going to have to use those properties. Do you want some time or some guidance on number 11? All right, so when I look at this one, I see that I have information about going from 5 to 2, and I have information about going from 5 to 9, but I want to go from 2 to 5, from 2 to 9. So what I can do is say, well, why don't I break that up using that first property, using the additive interval property, and I can say, well, I can go from 2 to 5 of f of x dx, and then go from 5 to 9 of f of x dx, and that will give me the area from 2 to 9, yes? So looking at the information I'm given, I have the area from 5 to 9, which is how much? Yeah, because then that's your opposite property. So 2 to 5, you could do this if you wanted, call that the opposite of 5 to 2 of f of x dx. So that's -3 plus 8, so it is 5. All right, last one. Now this one, we have information about f and g. I'm going to give you some time on this one. So for part A, we want to find from 6 to 11 of 9 times f of x dx. So one thing you can do is pull out that constant. So that's going to be 9 times the integral from 11 to 6 of f of x dx. And so I don't have information about 11 to 6, but I do have information about 6 to 11. Yeah, I mean, one thing that you could do is you can kind of look at this and say, well, that's going to be 9 times, and if 6 to 11 is negative 7, then 11 to 6 is going to be positive 7. So your answer is going to be 63. You can also say, well, going from 11 to 6, well, let's just do a negative 9 times the integral from 6 to 11 of f of x dx, and then that's going to be negative 9 times negative 7. So either approach that you take, you're going to get 63. It might be easier just to sort of say, well, if 6 to 11 is negative 7, then 11 to 6 is going to be positive. Not so much. All right, so for part B, we have a constant in front of the g and another one in front of the f. So we can split that up. I'm going to do it in a couple of steps. I'm going to say, let's call that the integral from 6 to 11 of 6g of x dx minus the integral from 6 to 11 of 10 times f of x. Yeah, you could do that at the same time if you want. I'm just going to do that right now. So 6 times the integral from 6 to 11 g of x dx minus 10 times the integral from 6 to 11 of f of
Can
x.
we just insert that?
Well, this is 10 times f, so it's not just 10, a constant function. Oh, like okay. So that would be using, I was using this property right here, the sum difference property. So if you have the sum of two different functions, which is what I have, I've got g minus f, then I can just split those to two separate integrals and add them, subtract them. So we're looking at 6 times the integral from 6 to 11 of g is 24. So 6 times 24 minus 10 times negative 7. Yeah, that's 144 plus 70 to 14.